Hello everyone, welcome to this my first ever series on mathematics. This is only my sake for learning, and it's not for the sake of you guys. If you don't want to watch, this is okay. This is for my own sake if I want to keep learning. So this is just about mathematics 1 for the University of Germany, if you ever take that as well. And we're going to be talking about the basic concept. So this is for chapter 1 for mathematical basic, and this is only going to be talking about the basic concept only. Tomorrow we're going to be talking about 1.2, and if you guys want to stay tuned for that, then it's fine. So for 1.1, it talks about the basic concept. Okay, we're first introducing the basic mathematical terms and the symbols that is important for further understanding the script. So we have to learn the symbols and the meanings as well. So we're going to be starting off with a very simple symbol. And let me just get my pen for a second. It will look like this. It has and something with a line here. Okay, so I'm not very good at writing, but we're just going to write as an N. But I'm going to put a picture here. Hold on, let me just take a second. Okay, I guess I can't copy it, but you can guess what I mean about when I mean N. So N actually stands for a natural number. Oh, sorry. N is for natural numbers. Oops. Okay. Natural numbers are considered as positive integers. So an example of a set, okay? What we mean by set is we mean by the symbol here, okay? And when we see by positive number, I mean like 1, 2, 3, 4, and etc. Okay? So yeah, there are infinite number of natural numbers, and this list can go on. It's basically a list of natural numbers that coordinates to this rule. Okay, so those are natural numbers. And the next one of the next symbol is basically oh wait, before we go to the next one, the next symbol, I need to talk about the distinction, the designation of the symbol. Okay, so when we designate for a symbol, for let's say n with 0, this is called a designation, right? So this 0 means that this natural number starts with a 0, and you might see this a lot where sometimes the n with the designated 0, it looks like a no, but it's actually a 0 here. It's actually a set, the same of positive integers, but with a 0 from the beginning. So yeah, those are designated for natural numbers. Okay. The next symbol we're going to be talking about is the Z symbol. So it will look like this. Yeah, it has this line in here. Yeah, it kind of looks similar to that. So this Z is actually stands for integers. Now, what's the difference between integers and natural numbers? Okay, what are integers? Okay, so integers can be positive and negative as well, right? And they can be subsequented between the destination, right? So the full Z, I'm going to write that as a normal Z. Okay, it has a full list from all negative numbers. It also contains a 0. It also contains a 1, 2, and 3, all natural numbers. So yeah, so a Z is considered as more bigger. To give you a better idea of the idea of what is integer and natural number, is that this circle can be considered as n, and this bigger circle considered as a Z. So everything inside the natural number contains the integers, right? Now, Sometimes for the designation it can start off with the plus, and this is exactly as a natural number. So it can be all 1, 2, 3, and so on. So therefore, the z plus is the same, or you can say it's the element of a natural number, and we're going to talk about these elements soon. So this is just a Greek symbol that we say is the element of. Is the element. Yeah. So every time we say these symbols on these number mathematical questions, we sometimes read them in English. So as z, positive integers. I say since this is a plus, designation plus, we say positive integers, is the element of all natural numbers. Okay, so this is how you read a basic, but we're going to be talking about that more later. Okay, but basically you should understand that the z is a full sequence of all the n. Okay, there's also a negative. There's also a negative integer. We say it like this. Okay, there's also a z0. Oh wait, no, there isn't. Sorry, it's just a negative. So that's all from all the negative numbers is going backwards. You know. Oops, sorry, negative 1. Now is 0 considered as a hold on for a second. So negative integers does not have a 0, and also positive as well. Okay, sorry, I was just making sure I had this. So yeah, so that those positive and negative integers does not have in this the set of the positive and negative. Okay, this is just to confirm everything as well. So the next symbol we're going to be talking about are called rational numbers. Hold on, let me just clear this out for a second. Yeah, rational numbers, and it has a symbol of, hold on for a second, yeah, it's like Q. Yeah, this is not exactly the symbol. You guys can search it up in Google. So it's basically, the idea is basically like a Q. Okay, this is a bad drawing, I'm so sorry. But we call this a rational number. And the rational number is a more bigger scale compared to the natural. So this is the natural. Oops, sorry. There's a typo here. I'm still working out the controls. So that's the natural number. This is the integers, and this is the rational numbers. Rational numbers. And by definition, a rational number is considered as all numbers that can represent as a fraction. Okay, and it's very easy to represent that. Okay, hold on. Okay, so let's say that we have p over q. Okay, and p is considered as a positive integer or negative number, and including the 0 as well. And q is either a positive or negative integer, but cannot, yeah, positive or negative, right? And with the symbol rational number, we can be example 3 over, okay, see? Yeah, so this is a decimal value number. We can actually use the calculator. What is 3 divided by 2? Okay, 1.5. Okay. Oh, sorry, negative 1.5. Okay. So this is is called a rational number, and it's all fraction number. So this is what we mean by rational, okay? And so we're getting closer to everything, to every single number. There's actually one more number that we're going to be talking about, but before I move on, I just need to confirm something. Yeah, there's no designation for a rational number. It's usually just a fractional symbol, you know, like a 3 over 5, 1 over 2, and so on. Even though it does end up, it can be considered as a rational number. So just like in a circle, the rational number, it contains everything from the natural number and the integers. It does contain, but it does not contain everything. We cannot say that the rational number is in the element of the is everything in the integer, because a rational number is a big scale of numbers, all from 0.11 to 0.111111 and so on as well. Okay, so that is rational number. Okay, and the last symbol we're going to be talking about is called real numbers, and this is a very easy thing to talk about. Yeah. So what is real number? Real numbers, sorry, are considered as numbers that is considered as imaginary numbers. Pi, and those are imaginary numbers. So example is pi. So yeah, the level of the simplest thing, you have to understand at least the basics of algebra and stuff. So pi is one example, and the imaginary number it's actually just an I, if I'm not mistaken. Yeah, so pi and I and so on. There's actually a lot of examples that we can give. Right now I can't think of it, but basically those are numbers that well, by definition it means both integers and all numbers in decimal places and so on. And yeah, designated integers as well. It can work for rational and real numbers as well. So if we say that r plus, these are all the positive numbers of the rational, the integers, and the natural numbers as well for the positive. So real numbers means everything that exists, including the pi and the I and everything. So every bit of number is there. Now people say that, what is the difference between rational and real numbers? Well, the difference is because not everything in the rational can be considered as like a normal number. The number in pi is a concept of a number that represents a circle, right? And this number is still going on to make a perfect circle, and we cannot define that number pi because that is still going on, is still proving, and is still going on as well. It's infinitely big. And I is considered as a square root of -1, which is of course not possible, but it is existed in mathematics, and it is a real thing. So this is categorized as a real number. Okay. Now the next thing I want to talk about is variable. What does variable stand for? So in definition, the variable stands for the mathematical expression, and a variable is a symbol, often the letters used of x, y, or z, which serve as a substitute for a known quantity in the expression. Now, if we take computer science, we can actually understand this very simply as well, okay? We take a symbol and then we put a value into them, okay? Sometimes we put it like in a lowercase, such as an x, y, or z, right? Oh, sorry, I pressed the button again. Oh, yeah. So we take x and we assign that to the number 5. Thus, when we say x plus 2, we mean 5 plus 2, which is equals to 7. So this is a variable, okay? That is actually a basic symbol of what a variable is. We should all know. Now, in mathematics, there's also a group of of variables that we should actually memorize and understand. Okay. Okay, so in mathematics we have these groups of letters that we have to understand when we assign these numbers. Okay, in mathematics we use Greek letters or Greek alphabet in our use, and since we follow the tradition in the script, the following information can be shown. I will give you the information now. Hold on. Yeah, there's a lot of information there. Okay, so that's C. Oops. There's also another one. Yeah, so these are all the, sorry I couldn't get to one image because the size of the paper, right? So yeah, these are all the Greek numbers that you can actually take a look and then we memorize them and everything else. Okay, sorry it's not being straight. Yeah, sorry for being not being straight, but basically this is the main idea. We have pi, right? We have c, nu, mu, lambda, and psi pi and everything else. So do we have to memorize them? Yes, we do. Oh, actually there's actually one more, sorry. Okay. So yeah, these are all the Greek letters that we have to memorize for the mathematics basic concept. Okay. So yeah, I'll just take the lead now since we just need to we don't have a lot of space. Well, that's the basic idea. Okay, and the value range of the variable determine which values the variable can be taken to take. Now, to take the express that a variable x can store numbers to a certain number set, we use the element, the e symbols. Okay. Hold on for a second. Yeah. So yeah, the first symbol that I taught you was the e, and this means is the element of. You do have to understand this, memorize it as well. So because we're going to be reading a lot of this symbols more than just writing, saying E, okay? Now, we're not going to say E, we're going to say in the element of every time we're going to be reading expression, okay? Now, in the mathematics, a distinction has 3 types of symbols, okay? And here are the symbols. We have the equals, and we have the semicolon equals. We also have not equals. Let's talk about the obvious one, and everyone knows the equal sign. The equal sign is exactly, it means that it's, how am I going to say this? And by definition, that symbol indicates the equality of the two expression. Okay, so you have a two expression. Hold on. Sorry for the bad writing. We have expression 1, and then we have the equal symbol, expression 2. Expression is basically like a mathematical concept idea, okay? And when we put this equal sign, it means that these two are exactly the same, okay? Well, not exactly, I mean that these two have an equality of information of each other, okay? The next one is the, hold on. Oh yeah, so the next one is the semicolon, that's equals to. So this symbol means, in simple terms, if you're a programmer, you can understand that this is actually equal by definition. What is the difference? What is the difference between this and this? Because a lot of people confused. They're not the same, but they have the same idea. Okay, so we talked about that the equal sign has expression 1 and expression 2, exactly the same, right? Yeah, when we say exactly the same, we're trying to prove that, for example, 3 minus 1 is equals to 2 times 1, okay? So they're exactly the same data and information because they are exactly the same. 3 minus 1 is 2, 2 times 1 is 2. And they have distinction. They have no distinction between each other. While equal by definition means that they are assigned. And we mostly use this for variable for computer science. And this is exactly what we talked about when we talk about variables. So if x, okay, by definition is equal by definition to 5. So they're not exactly the same. However, they have the same idea that x is implying to that data to 5, but it's not the same. Okay, this just by definition. Okay, that's the difference between the semicolon equals and that equal sign. And then we also have that the not equal sign. It's very simple. Yeah, it means not equals to. It's self-explanatory. So 1 is not equals to 2. Okay, why do we use this? Sometimes for proving that these two values are not the same. Okay, and that can be a good thing, that could be a bad thing, but in mathematics we need to prove a lot of things. Let's say that prove that x plus 1 is not equals to y minus 2. Okay, just for example, but we're not going to give too deep into the example practices since we're just taking a look about the symbols and practices and everything else. Okay, and so we learned a lot about equals, not equals, semicolon equals, and the element of, and there's also the 2 more symbols that we have to learn, and they're very simple. They have like this and like this. So what does this mean? So these symbols, okay, we're going to be talking about this one first. This is an abbreviation that we use to say and. And this abbreviation we use to say or. And this 2 symbol is mostly used for proposition between 2 expressions. Okay, we use like it's like normal English, but we're gonna give more deeper into these 2 examples later on into the subject of chapter 1. But basically, every time you see the symbol this letter up arrow, it would just say and V is or. To memorize it, I simply just like remember that up. It looks like an A, so it looks like an N, you know. And for this one, I just know it's the opposite of an N, but it's not really the opposite. I mean, like, what is the opposite for the opposing side? Okay, if you get what I mean. So, yeah, we're gonna be taking more into this example. Basically, to give an example, a very simple, quick example, just simple English that is how do I say it? Oh, sorry, it's still red. I don't like red. Okay, let me just try use English rather than mathematics since it's more complicated. It is raining. And cold. So in English, we say that the weather outside is raining and cold. Thus, these 2 statements is true. Okay. Yeah, there's a deeper knowledge between the proposition of expression by logic, but this is not computer science class. This is mathematics. So yeah, that is all for this video. We talked about symbols, we talked about the basic concept, and next we're going to be talking about proof and techniques. So I hope you guys enjoyed this video, and stay tuned for the next one. Thank you.